Hey everybody, Matt Morgan here. In this lesson we're going to talk about dimensional analysis from the OpenStax Chemistry Textbook, Chapter 1.
The purpose of this lesson is to introduce you to dimensional analysis and show you how you can solve problems using this technique. The first thing we'll do is explain what dimensional analysis is, then we'll work some examples on using this technique to solve various types of problems. So why should you learn dimensional analysis? Another name for it, you may have heard it called the factor label method. This is a very powerful problem-solving technique. You will use it throughout your career in chemistry, physics, any other science-related courses that you might take. Most problems, including a huge number of chemistry problems, involve using dimensional analysis. The sooner you master this technique, the easier it will be for you to solve these problems. Dimensional analysis requires you to do math on units as well as numbers. So what do we mean by units? Chemistry is all about measurements. When you measure a value in the lab, this includes a number and an associated units. How far, what volume, what's the mass? And when you work these problems, you want to deal with the units and the numbers as well. Okay, back to the lesson. There are three parts of a dimensional analysis problem, and if you can organize your given information and recognize these three parts, the problems become a lot easier to solve. The three parts include the given information, one or more conversion factors, and finally your target unit. That's going to be the answer that you want to work toward. You want to keep the target unit in mind as you set up your given information and your conversion factor. So let's go through some examples. We're going to start very simply, then we'll work on to some more complex problems. You've probably used dimensional analysis all the time, and you don't even know that you're doing it. So let's answer this question. How many eggs are there in 2 dozen? Hopefully you said 24. Well, in answering this question, you have applied dimensional analysis. Let's demonstrate how you did. Your given information was 2 dozen eggs. The conversion factor, 12 eggs, equal 1 dozen. Finally, your target unit is number of eggs. So what you want to do is take your given information, the conversion, you want to come up with your target. Let's set this up using a dimensional analysis grid. Given, 2 dozen. The conversion factor, 12 eggs equal 1 dozen. Finally, our target unit is number of eggs. So what we want to do is cancel the given units and end up with our target units. This is the key to dimensional analysis. In fact, this is so important, I'm going to say it again. Cancel the given units, end up with the target units. If you remember nothing else about this lesson, remember this one phrase. So dimensional analysis, it's really based on a property of fraction that you learned many years ago and have probably forgotten. If you have a fraction with a numerator on top, denominator on the bottom, if the numbers are identical, those numbers will cancel. Example, 2 halves, we look at that fraction, the 2's cancel. We end up with 1. This is what dimensional analysis is based on. Now let's go back to our problem. Given 2 dozen, conversion 12 eggs equal 1 dozen, our target is eggs. So how are we going to get 2 dozen to cancel? Okay, we're going to multiply them together. Our target unit is eggs, so what we want to do is we'll put eggs on the top. To get dozen to cancel, we put dozen on the bottom, and what we've done is set up a fraction that cancels what we don't want, leaves us with the unit that we do. Dozen cancels in our conversion with our given. The unit of eggs is left over, and that is our target. Okay, after we've dealt with the units, we multiply numbers that are on the top, we divide numbers that are on the bottom. In this case, we will multiply 2 times 12, divide by 1 if we want to. We'll get the same number whether we divide or not, and that gives us our answer, 2 times 12, of 24 eggs. That is an example of dimensional analysis in action. I couldn't resist. Gosh, that seems like a lot of trouble. Now, we don't have to set up a dimensional analysis grid to do a simple conversion like that, but that technique can be used for more complex problems. Let's move on to a different exercise still using dimensional analysis. In our next example, we'll use dimensional analysis to find the number of weeks in 133 days. Our given information, 133 days. Our target unit is weeks, and our conversion is 1 week equals 7 days. Let's set up our dimensional analysis grid. Given 133 days, conversion factor 1 week equals 7 days. Our target unit is weeks. Now we want days to cancel, so when we set up our conversion grid, days will go on the bottom. Weeks is our target unit, that will go on top. So your grid should look like this. Days cancel. What we do with the numbers now, we see that weeks is our target unit, that will be left over. We take 133 days, divide by 7, because 7 is on the bottom of our dimensional analysis grid. So what I want you to do now, take 133, divide by 7, press S if you want to pause the show to do the calculation, press S again to resume. I get 19 weeks. Hopefully you do as well. That's our second example. Now the first two examples that we didn't have anything to do with chemistry or science, but the technique we can use to apply to science and chemistry problems. Let's go ahead and do that now. This is a chemistry class. In our final example, we'll answer this question. How many grams are there in 2.4 moles of potassium? We'll see how we set it up exactly the same way as our previous examples. We'll find our given, target, and conversion values. The given information, 2.4 moles. Our target unit is grams of potassium. Now for this example, the conversion is not stated explicitly, but if we remember looking at the periodic table, an element's atomic mass is our conversion from grams to moles. Our problem-solving method will be dimensional analysis. We look at the periodic table, we find potassium. Potassium is K. There it is, element 19. Our atomic mass, 39 point, if we do 2 decimals, 10 grams equals 1 mole. 1 mole of potassium, 39.10 grams. We now have everything we need for our dimensional analysis grid. Let's set it up. Given 2.4 moles, conversion 1 mole equals 39.10 grams. Our target unit is grams. We want moles to cancel. 1 mole will go on the bottom. 39.10 will go on the top. Your grid should look like this. 2.4 moles, 39.10 on the top, 39.10 grams on the top, 1 mole on the bottom. Target unit is grams. What's going to cancel? Moles. We're left over with grams. Numerically, we'll take 2.4 times 39.1. Press S to pause this as you check my math. Don't trust me at all. I get 93.8 grams. Hopefully you do the same. So that's our examples of dimensional analysis. With this method, you can work simple unit conversion like we've done. You can do gas law problems. You can do thermochemistry. You can do stoichiometry, limiting reagent. There's all kinds of problems you will work with dimensional analysis. If you master this technique, the mathematical portion of chemistry will be very straightforward. This is one of the keys to succeeding in a general chemistry or really any chemistry course. So what we did, we defined what dimensional analysis was, and we showed some examples of how to solve dimensional analysis problems. What we did, we found our given information, our target unit, and our conversion factor. We set those up into a dimensional analysis grid. We canceled our unwanted units. We were left with the units of our target, and then we found our numeric answer by multiplying numbers on the top, dividing numbers on the bottom. Now the next step is for you. Apply what you have learned. Work the homework problems. Practice your dimensional analysis. This is a valuable skill. If it doesn't come easy initially, it will if you practice. Ask questions if you get stuck. We are here to enable your success. Good luck.
If you have questions, contact me via email at the address below. Also, we have online office hours Tuesday and Thursday mornings from 9 to 10 a.m. Central Time. There's the link to the online office, or you can also get to that through Blackboard. It's also in the course information. If those times are not good for you, feel free to contact me and make an appointment. We can meet online. We have a whiteboard. I can explain concepts to you and answer your questions.